Hi, my name is Eduardo Corpeño. I'm an electrical and computer engineer. I have been teaching engineering students for over 10 years now, and I want to invite you to take this course, which is a part of a series of courses titled Beyond Arduino, Electronics for Developers and Makers. This first part covers digital input-output. So why take this course? Because hardware is the new software. Lately, there have been several trends you may have heard of, for example, Arduino, the Raspberry Pi, the Internet of Things, and of course, the maker movement. So you may want to add hardware design to your bag of tricks. And maybe you may have become bored of the toy programs and libraries that hide so much detail to you. And this is an important reason. Maybe you don't feel like a beginner anymore. Maybe you feel ready to come up with your own solutions. And that's part of the knowledge that you will get from this course. So who is this course for? It's for makers who have some experience with hardware and would like to know how all this hardware works with as few equations and math as possible. Maybe you're a coder who was introduced to hardware through some development platform that's popular in the maker movement, for example, the Raspberry Pi or Arduino, and maybe you've done some basic stuff like blinking an LED or reading push buttons and whatnot. This course may be also for beginners, self-motivated beginners, who would rather skip all the boring theory and math and dive into the hands-on applications. Applications that move, light up, and make sounds. Or maybe you're a coder who got off with the wrong foot with electronics. Maybe you had a bad first experience with hardware and it's time to leave all that fear behind. Who is this course not for? This is not for advanced hardware engineers or electrical engineers. You will get bored with this course. It covers some VLSI. This is not an introductory microcontrollers course. You will not learn to use an Arduino board or any other board by taking this course. This is not a theoretical electronics course, so some basics are covered here, but we will not cover voltage dividers, impedance, or any basic topics. I do make some reading references in case you're not familiar with some of these terms. Next, this is not a programming introductory course. You won't learn C, Python, Java, or any other language by taking this course. This course assumes that you know some basic programming. And to get the most out of this course, I recommend that you get a development platform, anything from an Arduino or a Raspberry Pi, a TI Launchpad, a Freedom board, or you can even use standalone microcontrollers such as Freescale's SO8 architecture or Microchip's PIC microcontrollers. Any microcontroller will do. I also recommend that you get some actuators and sensors which aren't necessarily designed for your development platform. Anything you'd like to experiment with, bring it along. RC servos, LCD displays, any type of sensors, accelerometers, optical encoders, potentiometers, anything you'd like to experiment with is welcome in this course. Be aware that some knowledge is expected from you. To begin this course successfully, you must know how to run code in your development platform. Whether it's a BeagleBone or a TI Launchpad, you must know how to run a Hello World or blink an LED with your development platform. Some knowledge of basic electronics is also assumed. You must be familiar with Ohm's law, Kirchhoff's laws, series and parallel circuits, and basic circuit elements. You should also be confident with some programming language. You don't have to be a software engineer or anything, but you should definitely know how to write some code from an algorithm that's shown to you. So what will you learn in this course? Well, the most important teaching of this course is that there's more to life than the Arduino Uno. You'll see a lot of development platforms here. Second, there's probably a better way to do what you've been doing with microcontrollers. We'll show several algorithms that go into detail into how a software controller works. You may be used to using a library for this. Well, I'll show you how some of these algorithms actually work and how you can write your own functions. So in general, you'll learn how microcontrollers work, and you'll also learn how the supporting hardware works. I'm talking about input-output devices. And this point is very important. You'll learn how the functions in dumbed-down libraries work. If you're familiar with the Arduino library, you'll see that there's a lot of complexity hidden from you. We'll get to those details. Another very important aspect you'll learn here is to prefer interrupts to polling. So there's an efficient way of doing several things at once with a sequential microcontroller, and that's the interrupt handling technique. We'll do that briefly in this course, but I have a separate course dedicated to interrupt-driven embedded applications. Now, this is not exactly a hands-on course. What I'm offering you in this course is knowledge. You'll know how stuff works. So this is not a hands-on course if you don't want it to be. I'm not promising any projects you'll take from this course because I won't force you to build anything you don't choose to. For example, you will not leave this course with a surveillance robot that chases intruders while firing darts at them, recording a video of the chase and sending it to the police department. Nope, you won't go home with that one. However, I strongly suggest that you code along. Several microcontroller platforms are showcased here, but you should follow all of these examples with your own microcontroller. We won't get into detail on any of these microcontrollers, these are just examples. This course is supposed to be suitable for any development platform. Speaking of which, here are some of the development platforms I show in this course. There's the Basic SAMP 2 from Parallax, the Tiva-C Launchpad from Texas Instruments, the Nucleo platform from ST Micro, the LPC Expresso LPC 1114 from NXP, the SO8, the Coldfire, and the Freedom, formerly from Freescale, now NXP, and also a very cool Arduino compatible platform that's called the Teensy board. And this is just to name some of them. So roughly this course consists of 70% hardware, 20% software, and 10% demos. The hardware shown is the theoretical part, the software shown is from an algorithmic standpoint, and in the demos I'll show you an implementation of some of those algorithms on a specific platform. So we'll see the integrated development environment and the hardware working. We do have some quizzes along the course so you can test your knowledge, and I suggest some projects that you may build, but it's up to you to develop your own applications. So again, this course is part of a series of courses titled Beyond Arduino: Electronics for Developers and Makers. So the first part is on digital input-output. This is the one we're talking about right now. The second course is about microcontroller modules. For example, timer module for generating PWM signals, also analog input-output for reading potentiometers or sensors, and also serial communication, such as the SPI or I2C or asynchronous serial ports. And the third part is about interrupt-driven embedded software. I'll show you the interrupt-driven version of several hardware control techniques you may be familiar with in a polling implementation, which is very inefficient. So what does this course cover? Well, first there are some lectures on microcontrollers. We talk about the usual architecture, some development tools, why pins are usually multiplexed in microcontrollers. And then we have the main part of the course, which is general purpose input-output. We have roughly 1/3 of the course on digital input. We learn about input switches, matrix keypads, the transistors inside the logical gates, and several electrical aspects of digital input. Then we have digital output lectures. You learn some cool LED control techniques such as PWM and how to run a scan algorithm for LED displays. Finally, we have lectures on bidirectional input-output, pins that can be either inputs or outputs on demand. So we'll learn how that works and we'll see some applications of it. So come join us. Let's have fun coding with microcontrollers. I'd be honored to help you on your way to learning this exciting field of knowledge.